that's pretty exciting to be here. Thank you for having me today. So we'll be together for probably 15, 20 minutes. And I'll walk you over what we actually do at Koyeb and what we do with Vultr and how we basically enable serverless and global deployments across both GPUs and CPUs, leveraging Vultr's global infrastructure. So I will walk you through a couple of slides and I'll show you basically what the platform does and what we do together. I think there should be a live demo, but I must admit with the network today, we might need to skip it. So feel free to connect with us after because it's actually pretty exciting to see the demo also. So without further delay, let's get started. For some context, I'm Jan. I'm the founder and CEO of a company called Koyeb. I spent the last 14 years building cloud infrastructure. So I built two other cloud service providers before called Outscale and Scaleway. And since 2021, I've been building serverless cloud infrastructure with Koyeb. And that's what we are going to talk about today. To start with, I want to highlight something which is massive, which is what AI today represents already. So if you look at the numbers, today AI infrastructure represents 28% of the data center power used in the US. And that's just today, so knowing that we're just getting started. If you look at the forecast, we're expecting this to basically grow by 500%. In the coming years, in the next 4 years, we're expecting this to grow sixfold. And so this means a lot of power use, of course, and also cost related to this. If you look, the forecast says that basically today we're at like high percent of power used by AI infrastructure, and in 4 years we'll be at 14% of the US power used by AI infrastructure. Why does it matter? We're looking at two main challenges. We are looking at one challenge, which is that AI infrastructure deployments are mostly inefficient. And we see it from the software side. So we believe that infrastructure today is underused due to lack of capable software. And on the other end, we see another challenge, which is that all the AI and engineering teams are suffering from the complexity and from the cost of this infrastructure. So most organizations say they lack resources and or expertise. So now let's dive into what we are doing. We're a big believer in serverless. We started this company with the intent to bring a new generation of platforms to markets. We're bringing serverless capabilities because we believe it's actually the next generation of infrastructure. If you look at this whole timeline, back like 35 years ago, people were racking on-prem. And over time, we started like adding layers. So we started adding VMs, IaaS, Kubernetes, and we believe the next generation was going to be serverless, as that it makes even more sense for AI workloads, simply because you want more efficient use of your resources. We see serverless as a technology which applies to containers, functions, and database. And today we'll dive into how we apply it to containers on top of Vultr infrastructure to simplify deployment and increase efficiency. So what we do is we provide a high-performance serverless platform, and we enable more a container or continuous deployment on top of high-performance hardware. So we operate on demo infrastructure provided by Vultr and other partners, and we take care of managing the complete infrastructure through a free managed platform, so that you don't have to hire a cloud infrastructure team. We improve costs but with the serverless capabilities, and we focus on bringing increasing performance with the ability to deploy globally, and we'll dive into this point later. So to sum up, what we enable deployment of serverless container for high performance inference and APIs. So if you look at what we are doing, we operate, as I mentioned, on top of thermal. So we operate on top of Vultr and other binary providers. On top of this, we provide a virtualization layer to isolate your workloads. And on top of this, you have a container and the inference engine, which is going to be ready. And so in the case of accelerated infrastructure with NVIDIA GPUs, we'll be passing the GPU, which is hosted on the Vultr infrastructure, to our virtualization layer and to your end workloads. And we do this globally. So we operate across multiple locations. We're able to deploy on demand across the 32 global locations of Vultr, both across CPUs and GPUs. And we'll see what the network says right now. I'm going to do an attempt to show you, and I hope we'll get some network because it's actually pretty exciting to see in action. But basically, the way it works is you come with your model or your inference engine, and we take care, you pick your location. So you can pick a complete continent. For instance, you can pick US as a continent, or you pick a specific metro, and we will take care of orchestrating the workload. We'll take care of the auto-scaling part, the step to zero parts, and we'll distribute it across all the locations we select. So, and this works across all CPU and NVIDIA GPUs. It's exactly the same experience. And we'll see now if the network is working. So, let's see. Okay. And yeah. And I think we'll have to skip the demo for today, except if somehow it was right in the coming seconds. But because the network, so this is still open, so I'm absolutely not going to refresh. And I'm just going to show you quickly what we're actually seeing. So this is supposed to be on app.pet.com. It's actually my demo account. And thank you, JavaScript. It did an asynchronous call. So I cannot show you more, but what you were actually seeing is physical deployments, which were across CPU and GPU. So there was a global deployment. And basically, normally, we'll have to imagine together. You have our control panel where you select all the maps, the regions, you select your container. You can actually go directly from a mall, and you select the auto-scaling parameters. We can select from 0 to, for instance, 10 A100 GPUs. And depending on traffic, we will be adapting the number of GPU for you. And so this works across. You get another hotspot. We tried already a few.
There's Koyeb 25 back.
85 man. Okay. So we'll see if your ISP is better than Jack's one. It's actually an interesting exercise to see which one is walking. Whoa. And here we are back together. Okay, so we'll try to do this quickly. Basically, what you're seeing is our control panel. And if I go to koyeb.com/deploy, can I do more? Okay, great. So this is a set of one-click applications that you can deploy. It's just example. So you can pick from models, for instance, or you can pick directly an inference engine. If you pick VLL, for instance, and so I aim to show you an auto-scaling workload. Yeah, okay, let's do this. We'll pick DeepSeek L1 Llama 8B model, and we have a one-click option. And I'm going fast simply so that we see more things as the network gives up. I can actually pick the instance, and so typically we see that I'm picking a continental region, so it's going to spread across multiple data centers in the US, depending on availability. I could pick only Dallas, for instance. And so actually, in this case, if you pick A100, it's going to overflow between PCI Express cards and SXM cards, which are potentially in different facilities. But you can decide to pick one single location, and we actually operate across multiple location. And so I already have a quota. I actually deployed too many GPUs before. So anyway, this is another one which I deployed earlier, and it's the one which I wanted to show you, which is autoscaling. So we see here that's, and I'm going to zoom in actually because it's probably a bit small for you all. So we see that we have like a DeepSeek L1 model, 8 billion parameters. So it's actually technically a Docker container running on AL100, and it's scaling between 1 and 4 instances. If I go in settings, I see actually like the instance type. I can auto switch between CPU and GPU. If you click deploy, probably into transfer, you will deploy where you want. And I can see the auto scaling parameters. I can change them, scale to 0 or scale more, depending on the parameter I select. So typically here it's 2 requests per second. And yeah, and we saw the locations before. So if I go here, I see my deployments, I see the logs, and we are going to do something. And we see that basically there is only one instance which is running, and it can scale up to 4. If I go here, well, network is still working. So I have a shell, and basically I'm going to generate some loads, and we'll see together that depending on traffic, we'll bring up more GPUs to sell the application. And so here I'm basically launching the what it is actually doing is like it's launching the VLN benchmark, and it's doing it with 200k points. And it's going to take some time for the to start. I did it. It's just like it's a Python application which takes a bit of time to load. This is not network anymore. And basically, while this is happening, we'll see a more instance coming up online in a couple of seconds according to the number of requests there is. And yeah. And anyway, while this is happening, so this is a DeepSeek model in deploy, and I think it's like going to be
Last.
yeah. Let's go. Sorry, let me just like this. What is it?
See, so you're saying you have the different type of models. So I can come into your website or the app, and then I can select the model that I want to run, but I'll provide my data, right? And it is multi-tenancy, so I'll secure. I can run and get my results out and move on. So it's kind of like you are providing model as a service, like.
Yeah. So the question is like I think it's at which also layer we're operating, right? So what we orchestrate is containers, and so typically what I showed you is a one-click option where we actually bake the model inside of the container. But technically, we're giving you an abstraction to orchestrate containers across multiple locations, potentially multiple providers and different GPUs. And so, and it seems like sorry, okay, anyway. It's actually not testing on my DeepSeek mode. Anyway, the thing it's like the snap code should be our day. It's not the right comments. Okay, I'm not going to fix the prompt. Basically, it's not request to the right mall. But anyway, yeah. And so if we deploy, actually, last thing I want to show you, and then we'll move to the last slides and to any questions there is. We can deploy together a demo application from scratch, and we see that we can actually pick from the CPU and the GPUs, and we can actually deploy across multiple locations if we need to. So if I want to deploy across 6 locations probably, I can just pick the multiple locations, pick my auto scaling parameter and hit deploy, and it's going to bring this automatically up and online for me in less than a minute. And so yeah, just to move on to because I think like we'll probably be running out of time soon. So key features which are here to help you are scale to zero and also scaling across multiple locations worldwide. So when you deploy your model, we will take care of adapting the number of GPUs and increase the efficiency for you. So you can do it today. You can deploy serverless containers actually, which have mode inside of them, or inference engine, depending on the level at which you want to operate across the 32 global locations of Vultr. And you can do this in a minute. So basically, you see here that like what I just deployed is up and running. So the last instance is getting started, but I just deployed 6 containers in 6 locations worldwide while you are cooking. Nice, and that's it. So if you want to get started, you're welcome to get started here, to reach out to the virtual team, or to reach out obviously to me too. I'm happy to help to get started with the platform. What I showed you is live. I mean, we tested together the network, and basically it auto scales in minutes when I type the right commands. And that's it for me for today. Any